All right, guys, so we have another lesson on vectors, and this one is going to be very short and should be very simple. Seniors, this is your last official assignment, your last lesson ever from me. Would ideally finish on some sort of a quiz or a test or something, but in the situation we're in, we're just going day by day. So your last day is vector magnitude. So a vector is a symbolic representation of anything that has direction and magnitude. Magnitude is just another word for size. Now, size can be a physical thing like 4 inches or 5 units on a graph. It can be a size like miles per hour or force or all sorts of different things a vector can represent. But as far as what we're doing right now, the theoretical approach to vectors is just being mathematical objects on paper, the little arrows. There are 2 key components. There is the direction, which we covered last time, and then there is magnitude, which is the length of the vector itself. So the length, if I could spell length right, that would be cool, is the same thing as magnitude. Symbolically, let's say you have, oh gee, I forgot how to write a cursive V. No, is that a V? Holy cow. It's been so long since that's a V. What's a U? Oh my goodness, I'm embarrassing myself here. Well, I'll just use printed V's. See, vectors are, when you do this notation, they're in bold, and you can't really hand write in bold necessarily, so that's often replaced with cursive, and I, for the life of me, cannot think of how to make a cursive letter V off the top of my head. That's a U. Oh my gosh, this is killing me. A U is like this. A V is like that. That's right. And maybe sometimes like that. So if this is a vector V, the magnitude of V is written sometimes like this. Those 2 bars get used a lot. We know they mean absolute value. We know in matrices they mean determinants. So more often, here, let me make my cursive V again. Magnitude will be written like this. So kind of like double absolute value bars or something. But if you see that in the context of vectors, that means magnitude. Mag, because I abbreviate everything. Okay, so how do we find the magnitude of a vector? Well, the magnitude of a vector is simply, well, the length of a line segment, which is something we covered in the first week, I believe, of this class. When you have 2 endpoints, let's say x1, y1, and then x2, y2, to find the distance, we call it the distance formula. You did the square root of x2 minus x1 squared plus y2 minus y1 squared. So if you have the kind of vector where they give you the initial point and the terminal point, like down here, you would just plug those numbers into this formula and do it. If you have a component vector, or one that's in the ij form, where one point is always the origin, you can just say that 0, 0 is always that point, and when you subtract 0, nothing happens. So your distance formula becomes x2 squared plus y2 squared, and then square root it. So it's essentially just the Pythagorean theorem. So this becomes a very simple lesson. I'm not going to try that cursive V. The magnitude, well, here. Oh no. Well, guess what I did? I did 2 problems with direction. So I guess I better do this. My bad. Looks like a little review here before I get down to the magnitude. So 1, 7 is going to be up here. 1 is the x, 7 is the y. So the inverse tangent of y over x. And here I'm not going to have to add 180, subtract from 180, subtract from 360, nothing like that. I just need Desmos to do this. I'm sorry, I forgot I threw in a couple of review questions on direction. So let's see, make sure that I am in degrees, yes. And I want to do the inverse tangent of 7 over 1, which is just 7. So what is that? 81.87 degrees. 81.87 degrees. So review from the previous lesson. There it is. You do number 1, you should get 111.6. So give that one a try. Don't forget to graph it first. And that way you know if you need to add 180, subtract 180, subtract it from 360, whatever. Okay, back to the main point of the lesson, which is magnitude. So here is R. Can I do a cursive R? Boy, my cursive is awful. Let's just make this something like that. Yeah. Okay, so square root. Gosh darn it. We don't have to do y2 minus y1, x2 minus x1, just 8 squared plus 28 squared. Guess what? I need a calculator again because I can't do this without. I'm going to flip this over, guys. Pull that over. There we go. So square root 8 squared plus 28 squared. Oh, I'm forgetting something. Delete all this. 8 squared plus 28 squared. So this is radical 848. Now 848 is a radical that can be simplified, I believe. First of all, that's an even number. And that's an even number. What is that? 212. And that's an even number. And that's an even number. And then 53 I don't think will break down anymore. So we got a pair of 2's, another pair of 2's. So we can bring out 2 2's, radical 53, 4 radical 53. Or if I just want to do the decimal, oh, it's not going to work like that. Square root 848. I get 29.12. So you could express your answer as either a radical or a decimal. Let me check number 4. Ooh, is that right? Yep. Doubted myself for a second, but there it is. So look at all those answers. They're all given in radical form and decimal form unless they happen to be whole numbers. Okay. Well, that looks pretty messy. Let me straighten things up just a little bit before I go any further. So it's a component vector. That's all you have to do. You don't need to do the beginning point and ending point because the beginning point is 0, 0. So that makes it a little easier. Move that stuff out of the way. Okay, number 6. So the magnitude of bold R is the square root of 20 squared plus negative 21 squared. Now make sure you put a negative in parentheses. If I do 20 squared plus negative 21 squared without parentheses, I get a negative number, and then you can't square root a negative that's imaginary. That would be bad. So you have to have the parenthesis here and there, and then square that, and you get radical 841. Let me check the square root of 841, and that is a whole number, 29. No need to make a tree. That one actually works out to be a whole number, so there it is, right there. Oh wow, look how close, 848, 841, 29.12, 29. That's interesting. Okay, number 8, and we're done. So the magnitude of vector P, square root of 23 squared plus 29 squared. All right, let me get rid of all this stuff. 23 squared plus 29 squared. So that gives me square root of 1370. Now let's see, is 1370 a perfect square? No. I'm going to go ahead and jot that down. 37.01. But if we have to do the factor tree thing here, all right, a number that ends in 0, that's divisible by 10. And that's 2 times 5, but 137. Can you divide 137 by anything? 3, no. No even number. 5, no. 6, 7, 9, 11. All right, I'm thinking 1370 cannot be simplified into anything. Oh, and look, right there. And I didn't do enough decimal places. So let me get rid of this attempt at a tree because it was fruitless. Haha, get a fruitless tree. Wah, wah, wah. All right, and then bring this over. And so there are our 2 answers, our decimal approximation and our radical form. Okay, so this is stuff we've done before. Like I said, it's technically just the distance formula, but when one pair of numbers is always going to be 0, 0, it's like this part of the distance formula doesn't even matter. So it's really just that formula you need, one direction problem for review based on what we did 2 days ago, and then the rest magnitude problems. Okay, yeah, so do this, check yourself, do the odds, check them, turn it in. And seniors, sad times. It's not like we're in a classroom and I can actually say goodbye, but I hope you've made something out of this horrible situation we're in, and moving forward, I hope everything works out. So talk to me sometime, call, email, whatever. Maybe we'll do a Zoom meeting or Google Meet or something. But all right, I'm going to shut up and let you have your day.